Okay, peeps, I'm going to try this. Get a couple of problems up for you guys since I didn't have a chance to record it today. So, double check. We're 7.6 and 9.1. Let's double check and see if you can see that okay. Alright, we'll write a little bit bigger. I'm going to jump down to number 7 since I've had a lot of requests for that. And that is solving for sine of 2 theta plus cosine of 2 theta is equal to 1. Now remember, one of the keys of the 5.0 thorough level questions is that you're going to have to use some of the identities to do this. So a couple of things. First of all, sine of 2 theta, you only have one option. It's going to be 2 sine theta cosine theta. Okay. Now, for cosine of 2 theta, remember, grab a different color. Sorry for the delay. Now remember, you've only got a couple of options here. I'll bring this back. Is cosine of 2 theta is either equal to cosine squared theta minus sine squared theta. Okay, it's also equal to 2 cosine theta, 2 cosine squared theta minus 1. It's also equal to 1 minus 2 sine squared theta. Okay, so those are your options in terms of what to put in for cosine 2 theta. Now this 1 over here, ideally we'd like to get rid of it, because if we bring this over and we have to add it in, there's just one more part that we have to worry about. So if we take the 1 minus 2 sine squared theta, what that will do is it will simplify what we're doing. And so we're going to say, okay, minus, or that's going to be plus 1 minus 2 sine squared theta. So then the 1's are going to go away. So now I just have 2 sine theta cosine theta minus 2 sine squared theta equals 0. And then at that point we can factor this out. So I'll start there and then you guys can go ahead and finish this. So I'm going to have 2 sine theta times cosine theta minus sine theta. So then you either have 2 sine theta is equal to 0. That you will drive down. So theta now is going to equal, everybody, 0 or 90 degrees. This over here, a little bit differently, you're going to get cosine theta equals sine theta, because cosine minus sine is going to equal 0, so those two things have to be equal. Now, you could go through something really kind of long and convoluted, squaring both sides or things like that. You could actually solve it all out, or you could just think about it. Where is cosine theta equal to sine theta? On your unit circle, that is where you have a point root 2 over 2 and root 2 over 2. So that's going to be, theta is going to happen at 45 degrees, and then also at the negatives, which would be 225 degrees. So your final answer, 0 degrees, 45 degrees, 90 degrees, and 225 degrees. Okay, so that's 7. Hit pause now so you can go through and copy. For problem 8, similar sort of thing. So I've got root 3 secant of 2 theta is equal to 2. So that means that secant of 2 theta is going to equal 2 over root 3. Now before you guys start rationalizing this thing, think about this. We don't have an inverse secant button on your calculator. So that means you need to change this into something that's more usable. Now you could do this a couple of different ways. The full way to do it, saying, okay, well secant of 2 theta is just going to be 1 over cosine of 2 theta. So that's going to equal 2 over root 3. So since, if you take the reciprocal ones at both sides, that's a legal move. So then if you take the reciprocal of both sides, cosine of 2 theta is square root of 3 over 2. And you could actually just jump from this step down here, and I'd be okay with that. I'm going to go turn on some more lights. Ta-da! Okay. So from there, here's going to be the one thing. Theta is between 0 and 360 by what the domain is talking about. Okay? So that means that 2 theta, if I double that, is going to run between 720 degrees and 0 degrees. So on our circle, okay, cosine is equal to square root of 3 over 2 here at 30 degrees. And then you're going to go around the whole circle, and you can come back here, and you're going to hit another one at 330 degrees. Okay, and again, you can do that by your calculator and inflect it down. Oops, sorry, that was off the screen. So you're going to start at 30 degrees, you're going to come around, the next place is going to be 330 degrees. Okay, either do that by your calculator or remember off your unit circle. Now, because 2 theta is 0 to 720, that means that we get to go around a second time, which will give us a... So when you come around the second time, we've already gone around once, that's 360. Now we're on the second revolution, so that means that that one is going to be 300 or 30 degrees plus the 360 degrees. So that's going to be at 390 degrees. And we're going to come all the way around here, and then that's going to stop us just short of 720, which is going to be 690 degrees. Okay? So because of that, we now have 2 theta is equal to 30, the 330, 30 degrees, 330 degrees, 390 degrees, and 690 degrees. So to find out what theta is, we're going to divide each of those through by 2. So your final answers are going to be, let's make sure we're on the camera, 15 degrees, 115 degrees, whoa, 165 degrees, 195 degrees, and then 345 degrees. Okay, so that is how you do those. A couple of other tips on the other ones. On something, let's see, like on 13. And by the way, you can't get null sets on these because, again, remember, you can have parallel lines where you have the same lines. Where you've got 10x over 3 plus y over 3 is equal to negative 2, and x over 3 plus y over 3 is equal to 0. Multiply everything through here by 3, and this one all through by 3, whatever the common denominator is, and then these would turn into nicer numbers for you to use. Okay? So that's one thing to think about. The other thing to think about would be on a problem such as, let's say, 15. Some people in class were concerned about this. Okay, you already have one equation with only 2 variables in it. So then what I would do is that I would take these 2 equations and set those up to get rid of y, because then you've just got less work for yourself. So, okay, so then if I go through and I multiply this through by, oops, that's a plus. So if I multiply this all through by 2, then I get 2x minus 2y plus 4z is equal to negative 8. Those would go away. You get another equation in which to use. 3x plus 5z is equal to 0. And then you can solve, obviously, for one of those. Plug it in there. You could say z is equal to negative 5x. Plug it in. And away you go. So there's some pushes for tonight. Hopefully that'll tide you over. We'll see you tomorrow.